All right. Welcome to CXC Math TV. Today we're going to be doing. Sorry about that. Welcome to CXC Math TV. Today we're doing the Applied Mathematics Paper One, and you're wondering why we're doing Paper One. The reason why we're doing Paper Ones first is because Paper One come before Paper Two for this year. So for June 2023, Paper One is going to be before the Paper Two exam. All right. So we're going to do a couple Paper Ones first, like two or three, then some Paper Twos. Now, I'm trying to upload one video a day. Be patient with me if you are waiting them. All right. I'm doing one video a day. Can't do all of them in one day. Notice it's midnight and I'm doing some papers. So if this video is going to be beneficial for you guys, just do it from now. Just hit the subscribe button if it's your first time and hit the like button. It helps me a lot, and I hope this video will also help you a lot. So let's get straight into it. So it says here, which of the following types of data best describes number of birds? When you hear number, it's quantitative. That's quantitative. Now, also it says during the month of January. Now, once you're getting finite values, it's what we call discrete. So it's quantitative and discrete. That's option A. Number two, which of the following is correct about negatively skewed? If the distribution is negatively skewed, all right, then what happened is that if it's negatively skewed, then that means the mean bar x is less than the median, the middle value, which is less than the mode, which is the highest frequent value. So in that case, the mean is less than the median, which is less than the mode. That's when it is negatively skewed. So mean less than median, less than mode. Option A. No problem. Number three, it says now we need to work out the class width. The class width, remember, for 14 to 20 is 13.5 to 20.5. Now subtract them. 20.5 minus 13.5, that equal to 7 minutes. Easy. Question 4. This refers to the cumulative frequency curve, which shows the n marks in exam. And they say how many students scored less than 70. So all you do is draw a line from 70 marks going up. That's the critical value right there. That critical value corresponds to 100. So how many students scored less than 70? 100. All right, 100 students scored less than 70. And that's it. Easy. All right, I know my line is not straight. Just leave my line alone. Number 5. For a population divided into strata, under which conditions is it preferable to use stratified random rather than simple? Now use stratified random if there is some variation in our, if there's some variation in the strata, like maybe age category or weight difference or any stuff like that. So in this case now we look at if the stratas are different. That's when it's better. All right. Individuals in each strata are very different. Alright, so that would be option C. Part D now, which of the following is discrete? Discrete means finite number. Now, number of books is going to be finite. You can either have 10 book, 20 book, 3 book, or even no book as finite. Now, height of shelf cannot be finite. Weight cannot be finite. Time is definitely not finite. Those are continuous. Number 7, they want us to find the variance of this distribution. Remember, the variance is sigma square, and since the sample size is small, remember sigma square is equal to the sum of x square minus the sum of x all square, and then we divide this by n. We divide the total by n minus 1, but when it's small, we divide by n. So first we need is the sum of x squared, but we have an unknown value here. So first thing we have to find out what x is first. From the last past paper, I think x was 10. That was what gave us a mean of 5. But we can check it and see. I think x was supposed to be 10. Alright, because this came on the past paper we did, the 2020. 1 times 2 plus 2 times 5 plus 4 times 7 plus 10 times 6. It came on the last past paper. And then we divide it by the total frequency, which is 20. Yes, we get 5. So x is 10. This is 10. Alright. Now that we have x is 10, alright, now we can go ahead now and use that to find the variance. So now we need a x squared column. So let me put like a x squared column here. X squared. So 1 square is 1, 2 square is 4, 4 square is 16, and 10 square is 100. So that means the variance s square is sum of x squared. So add them now. 116 plus 4 is 116 plus 4 is 120 plus 1 is 121. This is 121 minus the sum of x would be, we'll add these now. 1 plus 2 plus 4 is 7 plus 10 is 17. So that's 17 square over n, which is 20, all divided by n. Not using that calculator, I'll use this one. I already have out this one. Don't need that one right now. Fraction button. 121 minus open. This is now fraction button. 17 close the bracket square over n. N is 20 divided by n, which is 20. That gives us the variance, and the variance is 5.32. I am not seeing 5.32. Sum of x squared minus the sum of x all squared. Did I put in sum of x all squared? And if I put n minus 1, 5.6. So I should be seeing 5 point something. Did I add something wrong? 14 plus 2 is 16 plus 1 is 17. N is 2 and 5 is 7. 7 and 7 is 14 and 6 is 20. And then x squared 100, 16, 120, 121. Guaranteed I added them correct. Alright, I'm guaranteed I had them correct. Should be 6.1 based on what I'm seeing, but something is off. Can you see what is off? N is the sum of f. That is what is off. Alright, because they give us frequency, that is what I forgot to do. Sum of fx squared, sum of... guys, sorry about that. It's sum of fx squared. See all these simple mistakes? Oh boy. Now, again, I wanted to show you the time. Guys, it's midnight, right? Haven't slept as yet. Extra classes in the day. Doing this for you guys. So if the video gonna benefit you, please subscribe and like. Alright? Doing it in the middle of the night, tired. Alright? But still gonna make sure we don't make as much mistake. So we work out now fx squared, and fx squared would be 1 times 2. Well, actually x squared is 1, and 1 times 2 is 2. Now x squared is 4. X squared is 1, 4, 16, and 100, since this x is 10. Alright, so now 4 times 5 is 20. Then 4 times 5 is 20. Then 16 times 7 is, I'm not so sharp in the night, so I have to use the calculator. 16 times 7 is 112. Then 100 times 6 is 600. So in that case now, work out fx squared, add them. 2 plus 20 plus 112 plus 600 is equal to 734. So s squared equals 734 minus sum of fx. Sum of fx now. Sum of f times x 1 times 2 is 2 plus 2 times 5 is 10 plus 4 times 7 is 28 plus 6 times 10 is 60. And so get sum of fx is 100, so it's 100 squared over n, which is 20 over 20. Now we're good to go. Put it in the calculator, 734 minus fraction 100 square over 20 divided by 20. That in the calculator. 11.7. I well shade 6.1. And that is not the answer. It just looked like that was the answer, guys. So don't do that. Do not do that. Please do not do that. 11.7. Now, what is a sampling frame? A sampling frame is just a list from which a sample is drawn. This one now, I'm positive this repeat from 2020, but I can't remember which one. But we did 2020 like day before yesterday. But I can't remember. Which of the following is true? I have to do it again. The distribution is positively skewed. First, let's find the mean. So the mean is equal to, work it out now. Just going to use a calculator to find the mean. So to find the mean, remember it is fx over the sum of f. 1 times 15 plus 1 times 15 plus 2 times 22 plus 3 times 11 plus 3 times 11 plus 4 times 7 plus 5 times 3 plus 6 times 2. They will divide it by the sum of f. We'll add up 15 and 22 is 37 and 11 is 48 and 7 is 55 and 3 is 58 and 2 is 60. Then we'll do our division and we get 2.45. So the mean is 2.45. That's bar x. Now the median, let's find the median. This is 15 and this is 22, that's 37. So the median would be at the 31st position. So the median is 2. Now if the median is 2, the mean is greater than the median. This is true. And then mean minus median times 3. That gives us that the distribution is positively skewed. So 1 and 2 is correct. Option C. Now I definitely remember this one. This is repeat from what we did the other day, from when we did the 2020. This was the 87 degrees. That one is a repeat. If it repeat and we remember, we don't need to do it. This one now, they do this one repeat? No. Now it says 2 pie charts are drawn to compare the total sales for the week. The radius of pi 1 while the ratio of R1 to R2. So they're asking for the ratio of their radius. Now remember, if you add them, you get what? The circumference. Now 4, 6, that's 10, and 17, and 26, and 10 is 36. Add this one, we get 10, and 19, and 29, and 4 is 33, and 16 is 49. Now remember, to find the radius for A, remember circumference is 2 pi r. So 49 equal 2 pi r, then r is 49 over 2 pi. And that would be for R2. And then for R1 is just 36 over 2 pi. So that means the ratio R1 to R2 is 49 over 2 pi. Well, R1 is 36 over 2 pi. And then we divide it by R2, which is 49 over 2 pi. The 2 pi's would cancel, so it would become 36 over 49. That's option B. No problem. Now it says a pie chart with radius 8 cm is drawn for a third outlet. Using 6 cm as the radius of the pie chart outlet A, the total sales of C in thousands of dollars when compared to outlet A is 64. That's it. Because if the radius is 8, look what we're saying. The radius of A is 6. And we get circumference 36. So if the radius is 8, notice you just square it. This was also a repeat. We did this one already as well. Now, number 13, the median class. Best way to do this is to create the column that says cumulative frequency. 3 plus 5, 8, 8 and 8, 16, 16 and 10, 26, 26 and 18, 44, and 12, 56, and 4, 60. Now the median class is, since it's 60, we need, where is 30? Where 30 at? Where's 31 at? That's in this class. That's 24 to 26. Option C. Number 14. I know this repeat, but I can't quite remember the answer, so do it again. X1 plus X2 plus X3. They say when we add those three, the mean is bar X, so divide it by 3, the mean is bar X. Then we add the other three, Y1 plus Y2 plus Y3, and divide it by 3, the mean is bar Y. Now they say, what is the mean of all 6 numbers? So if we add all 6 numbers, x1 plus x2 plus x3 plus y1 plus y2 plus y3, if we add them, that would just give us, if we cross multiply, that's 3 bar x plus 3 bar y. So if we want the average of those 6 numbers, so to divide this by 6, we divide the result by 6. And so 3 over 6 is half, so that's bar x plus bar y over 2. That's easy. That's what they really ask. That's B. Number 14, what's the variance of the following numbers? Remember, the variance is the sum of x squared minus the sum of x all squared over n divided by n when the sample size is small. So in that case now, it is just now sum of x squared will add 6 squared plus 9 squared plus 7 squared plus 5 squared plus 3 squared plus 7 squared plus 7 squared. I'm going to use my calculator. Nobody has time to work out all of that, right? Nobody has time to work out all of that. So now we have 6 squared plus 9 squared plus 7 squared plus 5 squared plus 3 square plus 7 square plus 7 square. We work out all of that and we get 298. So far s squared equals 298 minus sum of x. Now add them easy, we don't need calculator. That's 15, 22, 27, 30, 37, 44. So minus 44 square over n. N is 1, 2, 3, 4, 5, 6, 7 divided by n, which is 7. I'll put that in the calculator. Now 298 minus fraction button 44 square over 7 over 7. We'll work that out and we get 3.06. That's it, 3.06 is the variance. I wonder why them ask us for the variance twice as opposed to the standard deviation. Now number 2, this one repeat, I remember it was 0.9. Just to show it again, mutually exclusive, this was A, this was B, A is 0.2, B is 0.1, outside is 0.7, and then they wanted A union B, this is A, union B complement, which is on the outside, 0.9. That's a repeat. I remember this one also repeat. So if you do enough papers, this was 1 over 15. Repeat 1 over 15. Which of the following describes normal distribution? It's bell shape, it's symmetric. So that's 1 and 2. Now this one now, to work this out, it's going to be phi of 2 minus phi of negative 1. But it's now phi of 2 minus in bracket 1 minus phi of 1. Then this becomes phi of 2 minus and minus will become plus phi of 1, subtract 1. So add them, then minus 1, D. Number 20 is also a repeat, but I just don't remember. So working this out, they want us to work out probability of L prime given B, which you know is probability of L prime intersect B over the probability of B. L prime and B, so L prime and B, multiply them 0.6 times 0.75, because this would be 0.75, over the probability of B is 0.6, and we get our 0.75. Number 21, I know this is a repeat, but this is phi of minus 1 minus phi of minus 3, which is 1 minus phi of 1 minus 1 minus phi of 3. Then this becomes 1 minus 1 cancel. Negative and negative let it become positive phi of 3 minus phi of 1. Option B. Number 22. 10% of the bulbs produced of a factory are defective. So this is binomial distribution, and it's N 400 and P is 0.1. The variance is, remember, var x is NPQ. So it is now 400 times 0.1 times 0.9. You put that in the calculator. 400 times 0.1 times 0.9. Put that in the calculator, that's 36. Option D. Very easy. Now it says a standard deviation of a discrete random variable. Remember, standard deviation of x is now the square root of var x. That's it. Square root of the variance. Find the probability x is between minus 1 and 1. We're in this region from minus 1 and 1. Add them. 0.2 plus 0.1 plus 0.3, 0.6. Done. This is a repeat again. Repeat. And I remember this was 0.229. Now, if you don't believe it, what's the probability that the height was less than 200? Just to work it out again, x is less than 200. First, standardize it. Z is less than 200 minus the mean 215 over the 20.2. Put that in the calculator. 200 minus 215 divided by 20.2, which is negative 0.74. Probability Z is less than negative 0.745. And that works out to be 1 minus the probability Z is less than 0.745. Then we'll look in the normal table at 0.745. So 0.745, this is 0.7, 0.74. The intersection between them is this right here. But it's not quite this because it should be in between 0.745. So it's somewhere up to 0.773, somewhere closer to that. The actual thing was 0.771 right here. Then we'll subtract that from 1. So B was our answer. 26. It says these are independent events. If they're independent, then the probability of x intersect y is the probability of x times the probability of y. So 1 over 15 equal 1 over 9 times the probability of y. And we'll do the division, so the probability of y is, do the division for me. We have 1 over 9 divided by 1. Well, 1 over 15 divided by 1 over 9. Put that in the calculator. 1 over 15 divided by 1 over 9. We'll put that in the calculator and we'll get 3 over 5. It's that easy. 3 over 5. Finish. Number 27. In each round of, oh, this was a repeat again. I remember it was 3 in bracket. 1 minus p over 5. This is a repeat from what we did the other day in 2020. Now, events A and B are independent. If they're independent, then we know 2 is true. If they're independent, Which of the following is true? The intersection is not 0. What is that talking about? That's crazy. Right? So we know this is true, and if it's independent now, then the probability of A given B is equal to the probability of A intersect B over the probability of B. So the probability of A intersect B is the probability of A times the probability of B over the probability of B. Then these cancel each other which just leaves the probability of A. So therefore 2 and 3 is true. So 2 and 3 is option C. Finish. Question 29. I remember this repeat, but I can't remember what was the answer. So we're gonna have to work it again. So it says it is estimated that 30% of the population holds a university degree. So X follows a binomial distribution. 10 citizens at 30%. The probability that at least one hold a degree is the probability X is greater than or equal to 1, which is 1 minus the probability X equals 0. So it's 1 minus, this is 10, choose 0. This is P now, 0.3 to the 0 times 0.7 raised to the 10. And I'll put that in the calculator. So bring out the calculator. 1 minus 10, choose 0 times 0.3 raised to the 0 times 0.7 to the 10. And we get 0.972. Option D, 0.972. Now number 30, this one now, we have to standardize it. So the probability Z is less than 33 minus 35 divided by the square root of 56 give us a standard deviation. That would be when we standardize it. So we're looking for that one. 33 minus 35 over square root 56. That seems to be option B. Number 31, in hypothesis testing, at 5% level of the significance, the null hypothesis is, now this is what we call the 5% significance level. This is a type 1 error. This is type 1 error. What gives us 5%? Type 1 error, you have to remember, is when HO is rejected, and HO is rejected when what happened? Given that HO is true. So that's what we're looking for. The null hypothesis is rejected when the null hypothesis is true. So rejected when it is correct. So it's rejected when it is correct. So that's what we mean. Alright, so just to show you, here it is at 5% significance. This is it. This is it. Alright, so type 1 error, it's rejected 5% of the time when it is correct. Yeah, that's a significance level. Alright, and 95% of the time it's accepted. Good. So that's it. A. Now, number 32, it says if random samples are drawn from a population which is not normally distributed, then using central limit theory, we approximate it to be normally distributed when n is greater than 30. So it's approximately normal distributed when n is greater than 30. Alright, that's the sampling distribution. Easy. Number 33, in a one-tailed test, the null hypothesis HO is 30, H1 is mu greater than 30. At the 10% significance level, the critical Z region or your rejection region. Remember your rejection region then is going to be when Z is greater than Z alpha, and alpha is at 10% significant level. So looking at when it's accepted 90% of the time. So Z is greater than, you go into the table and look at 90%. You're looking for 90%, 90%, 93%, 91%, 90. Where is 90? Here is 90. In between This look like 1.28 and 1.29. So I'll go with 1.285. So that's in between. So 1.285 or 1.282. That's it, 1.282. Easy. Next one, number 34. It says work out now the correlation coefficient. The correlation coefficient R is the sum or n times the sum of xy, n times the sum of xy minus the sum of x times the sum of y over the square root of n times the sum of x squared minus the sum of x all square, and then this is multiplied by n times the sum of y squared minus the sum of y all square. It's a lot of work, but it's not that much. So r is equal to n. N is 9 different occasions, 9 in bracket. X times y, 1960, minus sum of x, 68.8, times sum of y. Sum of y was 180, over square root of what? N times, so 9 times, sum of x squared, 753.9, times, minus rather, sum of x, 68.8 square, that is then multiplied by n times, so 9 times, sum of y square, 5100, minus sum of y, which is 180 square, close up the bracket. Put all of this in the calculator one time. It's a multiple choice. You're not getting marks for working. Put it in the calculator one time. 9 in bracket, 1960, close the bracket, minus, open the bracket, 68.8, close the bracket, times 180, over square root, this is 9 in bracket, 753.9, close the bracket, and open another bracket here, minus, this is, open another bracket, 68.8 here, close the bracket, open another bracket, 9 times 5100, close the bracket, minus 180 square, close that bracket. I'll put in the calculator. Ooh, 0.999. I am tired from doing that. That one was tiring. Number 35, this is a big repeat. We need to remember, when do we use a t-test? We use a t-test when it's not normally distributed and n is less than 30. The sample size is small. So not normally distributed, its population variance is unknown and the sample size is small. Done. Number 36, in a t-test, the degrees of freedom is equal to n minus 1. This is 8 we made. So 8 minus 1 is equal to 7. Done. A chi-square test does not use two tests, that's wrong. Use null and alternate, that's wrong. Test whether or not two variables have an association. Use a parameter called the number of degrees of freedom. Of course, with the chi-square, we do have degrees of freedom. Degrees of freedom is n minus 1. So, or it's equal to column total minus 1 times row total minus 1. So it does use degrees of freedom. So it does do this. Alright. It does use two-tailed test, and it tests whether or not two variables have an association. I don't like the wording of this because we do use null and alternate. A chi-square test. A chi-square test. A chi-square test is used with null and alternate, and we do use it for two-tailed tests. Alright, so Right here now, test whether or not two variables have an association. Now this wording, listen why I'm having puzzle with this, because I could say something like the null hypothesis is we're testing to see whether students study time impact grades, and then alternate now is student study time does not impact grades. In that case, it is showing the association between two variables. It is student study time and grades. So I would argue that it does give this. A chi-square does give an association. Test whether or not two variables have an association. It does. And it does use alternate and null. Now, using two-tailed test now, I guess I would go with D then. It's in between B and D, but I would go with D because with chi-square now, it's a little bit different. I guess it's, yes, I get it now, the D. So with chi-square now, we have to remember um, when we're looking at rejection region for a two-tailed test, it's slightly different than the normal two-tailed test. We either say that the chi-square is greater than chi-square of alpha, or we say that chi-square is less than the chi-square of in bracket 1 minus alpha over 2. All right, it's not written how we usually write it for the usual two-tailed test. All right, so use a parameter called the number of degrees of freedom. It does, yeah. Now this one says, which of the following is appropriate for the use of central limit theorem? We use this when the sample size is large, that's over 30. So large sample size from non-normal population, that's A. Easy. Number 39. It says the grades are given by 3 teachers at a school in a 3 by 5 contingency table. It says the chi-square test value calculated. The critical region is, so if we want the critical region, it depends on which of these two you're using. If you're using the one chi-square calculated is greater than chi-square of alpha. If we're using this one, then at 5% significance level, all right, so now this is what we have. It's not normal. And then remember, it's n minus 1 degrees of freedom. And n minus 1 degrees of freedom come from, this is 3 minus 1 times 5 minus 1. So the degrees of freedom is 2 times 4, which is 8. So 8 degrees of freedom. And so now we'll go and look at 8 degrees of freedom. 8 degrees of freedom. Here is 8 degrees of freedom. And we're looking at 0.05. So this is 0.05. That's 2.73. All right. So in that case now, this is chi-square should be greater than 2.73. Or the alternate now would be to work out this one down here. Chi-square less than chi-square of 1 minus alpha over 2. So chi-square is less than chi-square of alpha is 5. 5 over 2 is 2.5. 100 minus 2.5 is 97.5. So what we do is we look in the table at 97.5. 97.5%. And this would be 8 degrees of freedom. 97.5 is 17.53. So the next answer is our chi-square is less than 17.53. That is not there. The only one that's there is option A. No problem. Option A, option B. That's crazy. I put A. That's crazy. Option B. Now, this one says, when 60 random sample size of 45 taken, 90% confidence interval, and it's found that blah blah blah, the expected number of samples that do not contain mu is, so if it says it's a 90% confidence interval, right? 90% confidence interval, and a random sample of 60 is taken. So 10% might not contain mu. So 10% of 60 is just 6. So 6 is expected to not be inside of that because we're 90% confident. That's easy. Now it says the linear regression line of y on x passes through the point 0, 6. If x and y are 6 and 8 respectively, we pass through 0, 2. This means if x and y are 6 and 8 respectively, the equation is, the first thing we need is notice they give us the linear regression and y passes through 0, 2. This means if x and y are 6 and 8 respectively, so x is 6 just for clarity and y is 8. Alright, so first thing is the gradient. Alright, the gradient is, alright, so x is 6, y is 8. I don't like that. The point is at 6, 0, and this point is 8, 0, or 0, 8. Only thing is that one thing we're for certain positive with is that the y-intercept is 0, 2. I don't like how they word this. Alright. One thing for certain is that the y-intercept is, here is the y-intercept, plus 2. So we already know C and D out. 0, 2 indicates when x is 0, y is 2. Alright, so it only can be A or B now. Now, what's puzzling now is how they say this. This means if x and y are, if x is 6 and y is 8. So I'm going to use that point then to find gradient because I also know maybe they're giving us that one point is 6, 8. I'm going to take it as that. And the next point we know is x is 0, y is 2. So now we just need to find the gradient, which is 8 minus 2, y2 minus y1 over x2 minus x1. 8 minus 2 is 6 over 6. Gradient is 1. So therefore, y is equal to 1x plus the y-intercept 2. Option A. Okay, it's not bad then. Now, this right here, this is the gradient. What's the interpretation of 0.95? That is the gradient. So what is gradient again? Remember, gradient is change in y over the change in x. That's gradient. Change in y. This is y, and this is x. Gradient is change in y over change in x. And this gives us something. This is giving us 0.95 per 1. 0.95 what? It says y was $100 associated with producing X component. So this is telling us it's 0.95 hundreds of dollars per X component. That's all. So it says for every additional component of X that is produced, the cost will, and it's in hundreds. So 0.95 times 100 is 95. Automatically it's C. So for every additional component of X that is produced, the cost will increase by 95. Option C. Very easy. No problem. Number 43 now, it says the critical value at 5% significance level appropriate of a chi-square test with 12 degrees of freedom. So I love to do this at 5% significance level. At 5% significance level, you will use our table here, 5% significance level, that's 0.05. At 12 degrees of freedom, that's 5.226. That's all. Option A, finish. Now it says item 44 refers to the following information. The unbiased estimate of the proportions. So P, remember, is x over n. So we add up everything and divide by n, and n is 40. But don't add up everything, thank God. we need the proportions, which is the number of scores less than 20. That will be our x. So count them: 1, 2, 3, 4, 5, 6, 7, 8. I get 8 out of 40, which is 1 over 5, which is 0.2. Then finally, it says 200 samples are chosen, and the confidence interval calculated for 10 of those samples are not expected to include the population mean. So 200 samples, right? So we use 200 samples, and 10 are expected to not be within that. So 10 over 200, put that in a calculator, 10 divided by 200 is 0.05. So if 0.05 is not in it, 1 minus 0.05 is 0.95. So it's a 95% confidence interval. Very easy. Easy. And that completes the paper. That completes Applied Math 2019 paper. I really hope this video helps. It's very easy. All right. And you're using it for practice. Make sure to just like, subscribe if the video benefit you. And remember, I'm going to upload all paper ones from 2016 to 2022 and all paper twos as well, but one paper at a time. Just give me some time. We're trying to do one paper a day, right? And if you do pure with applied as well, I still have unit 2 papers and some more stuff to do, but one at a time, all right? So hope the video helped you, and I wish you all the best practicing, getting ready for exams. All right.